Uh, Good morning, everyone. I welcome to the series of webinar. Welcome to the next series of webinar. SCGJ completed 30th webinar in this series. Today we have a very learned and speaker who will be sharing his expertise and experience on various energy systems, parameters and roles, etc. Before I'll go to read his profile, I would like to Nija ma'am to welcome Mr. Japen Gaur. Ma'am. Okay. Ma'am is I think not available right now. Mr. Japen Gaur is a certified master trainer and course designer and solar energy consultant. Mr. Gaur is a proprietor at GORenewable technology, working on project proposal, technical, financial feasibility, designing, installation and operation and maintenance of solar PV rooftop system and megawatt utility scale solar power plants. He possesses strong knowledge of SketchUp and PV systems softwares. He is a consultant and third-party inspector for solar PV power plants for more than 9 years. He is certified master trainer in solar energy technology and has trained more than 5,000 participants in solar energy technology. He has carried out various corporate trainings, has addressed national level government and non-government seminars as a principal trainer. He has designed courses in solar energy and renewable energy sectors for various universities, colleges, and institutes. Mr. Gaur holds postgraduate degree in environment and energy engineering from the University of the Sheffield, UK. During his academic tenure at the UK, he had worked on various research projects such as solar thermal heating, cooling mechanisms, solar wind hybrid system, and more. He holds certificate in wind energy from Technical University of Denmark. He is an active researcher in renewable energy sector and has published various research papers in reputed international journals. He is editorial board member of International Journal for Innovative Research in Science and Technology journals. Now, I would like to hand over Mr. Japen Gaur to start his presentation. Thank you.
Thank you very much, Singh sir. Thank you very much for the wonderful introduction. I hope I'm audible to everyone.
Yes, sir.
So I'm going to directly dive in the today's session that we have gathered here for.
Sir, sorry for the interruption. Do you have the presentation?
And so, yes, I have just shared the presentation. I hope it is visible to everyone now.
Yes, sir. Yes, sir. It is visible. Sir. Thank
you. So, the session that I have planned today, and we are going to have a good look about it, is the introduction to energy storage systems, their parameters, roles, and various applications of the energy storage systems. I'm going to talk about various energy storage systems, and we are going to understand the principle behind those different types of methods, different types of principles. We are going to understand where those type of energy storage systems are applicable, what are their roles, what is the requirement of such energy storage systems, as particularly when we are talking about the renewable energy systems being the dominant in very near future. So this energy storage systems, they are going to become a part of the mainstream power requirements, because there are certain challenges associated with the renewable energy storage systems as well. So these are one of the solutions that we can look at, and what to expect from such technologies, what is the scale, etc., etc. So let's start with the very first things. The thing is, what we are looking at this point of time in power sector in India is more than half of our power requirement is still being addressed by fossil fuels. However, in past 10 to 15 years, we have seen quite a surge in renewable energy utilization, whether they be decentralized systems or they be megawatt scale power plants where the entire solar or wind farms have been developed, and those electricity has been injected into the grid to provide the support on the national grid and certain villages or even the big cities. So as and when these renewable energy systems are becoming dominant, there are certain challenges associated with these renewable energy systems which are required to be addressed when the system will become more prominent. Those challenges are supposed to be addressed by these energy storage systems, because they are not the renewable energy sources are not quite consistent compared to fossil fuels, basically. So in case of fossil fuels, we have certain calculations and we have certain knowledge that if we insert X amount of coal into the power plant, it is definitely going to produce Y amount of electricity 24/7, 365 days a year. However, of course, as we know that there are major challenges or major disadvantages associated with fossil fuels. Renewable energy sources such as solar or wind or hydropower plants are a necessity of the hour. This is kind of a requirement now, so we have to switch over towards the renewable energy sources. So as I said, more than half of the requirement is still being addressed by fossil fuels. The reason behind that is there are certain challenges associated with renewable energy sources, as especially when it comes to the integration to the grid. Basically, this renewable energy sources can be decentralized. However, they are not consistent. They have a fluctuating nature in the fuel itself. So the amount of electricity which is being produced, they can be disturbing. They can be unpredictable at certain point, and during those unpredictable time, the energy storage systems, they do kick in. As There could be a certain level of a dive in wind energy, there could be certain level of dive in solar energy in some time, and since we don't have any control over the sun or wind, we can have this energy storage systems as the backup. That is the motive behind the entire technology, basically. Unpredictable nature, as I already have said. During the peak demand and supply, the renewable energy sources might lag behind. I mean, in some cases, you can run the thermal power stations up to their peak capacity and can produce certain energy when the demand is increasing. You can forecast the demand. You can forecast the supply at the same time as well. Of course, you can forecast the demand, but you cannot completely forecast the supply in case of renewable energy sources. So to meet those gaps, these energy storage systems, they kick in and they come into the picture, basically. So what are the reasons? We have already said that, like, they improve the reliability. They improve the reliability of the grid. So the systems or the power consumers who are connected on this particular grid, they can be rest assured that electricity can be supplied 24/7 if we incorporate such energy storage systems into the backup system, as a backup system, basically. So to improve the reliability and resilience of the grid, energy storage systems in terms of renewable energy, they come into the picture. They increase the dispatchability. They reduce the environmental impact, because we are using the RE systems. They reduce the environmental impacts. And So basically, you can consider these energy storage systems as a side hero or a sidekick of any superhero. Basically, renewable energy sources are superheroes, but almost all superheroes, they do have their sidekicks to help them, to assist them. These energy storage systems are the sidekicks of our superhero renewable energy systems. So if I'm supposed to classify the energy storage systems, I would classify them into four major categories, basically. One would be low power application, medium power application, network connection, and power quality applications. Network connection and power quality applications are the applications where the grid and the uh, a bigger picture that come into the picture, like the bigger requirements, they do come into the picture. Network connections and power quality applications where grid comes into the picture. In terms of small or medium applications like mini or micro grid systems, low power applications or medium power applications, they are the kind of energy storage systems that can be incorporated. They can be associated with the renewable energy systems in terms of supply. So what are the different types of energy systems that can be incorporated in terms of low and medium power, such as a flywheel or chemical energy, compressed air? These are certain types of the energy systems which are on a very theoretical basis, to be honest, at this point of time. I mean, many of these have been used as a pilot projects, but we have not seen them into the fully functionals, or we have not yet seen them into kind of commercial applications as of now. But these are the big concepts which we might see 10 to 15 years down the line. When we are talking about the network connections or power quality applications, there is a gravitational energy system, which is kind of a very popular energy storage system at on a paper. Thermal energy, chemical energy, compressed air systems. So except different types of energy systems can be incorporated based on what are the requirements of systems, or what are the parameters of the system, and different scenarios are supposed to be drawn before we decide which type of energy system is supposed to be implemented along with our renewable energy system. So as I said, different parameters are supposed to be checked before deciding the EES, energy storage system. These are some certain parameters which we are supposed to have a good look at, being efficiency of the energy storage system, number of cycles it can run up to, what are the power transmission rates or discharge rates, how quickly that energy storage system can release the energy, and not only how quickly it releases, for how long, the duration, for the how much period that energy storage system can deliver the energy. I mean, let us suppose we have a solar power plant, and if solar power plant is not running up to its peak for 20-30 minutes due to some cloudy weather or something, so do we have any energy storage system which is supposed to, which is able to provide that backup for 20 minutes or 30 minutes? So that is the discharge rate, how quickly and how long the duration that energy storage system can supply the electricity to the grid as a backup. And not only the discharge thing, how quick that system is going to be recharged when my main technology comes back. Let's say that the clouds are gone and the solar system is now producing enough energy and it is recharging my energy storage, then how quickly that energy storage is being recharged. So recharge rate, discharge rate, the duration, power density, energy density, these are certain parameters that we are supposed to take care into consideration while deciding the energy storage systems, basically. So power density is kind of a the wattage that we can store in given volume. So higher the power in lesser volume is better. That is a higher power density. Uh, Similarly, energy density, like energy is power times time, right? So that power that we have stored in given volume, how long that can be supplied to the grid, that is energy density. Higher the energy density, better the energy storage system. higher the power density, better the energy storage system. But however, when it comes to the balancing of power and energy, we mainly focus on energy density, because we want to have power for a longer duration as well. In some cases, what happens is, if the system is not able, I mean, it is able to store more power, but it is not able to deliver that power for a longer period of time, then it might not become feasible. So power density and energy density combination is one of the basic important parameter that we have to look while deciding the energy storage system. And obviously, the most important parameter, that is cost, finance. Renewable energy storage systems are kind of expensive as of now. I mean, obviously, the cost has gone drastically down in past 10 years, and the entire system has become more and more feasible. But when we are talking about incorporating another energy storage system, such as batteries, for example, the incorporation of the batteries will cost. Not only the incorporation, but the operation and maintenance of batteries will also cost. So the finance part of the energy storage system, that also becomes very critical while deciding a backup, a side queue. Like, how soon do I need to replace those energy storage systems? I mean, for example, the batteries, they might last for 5 years or 6 years, but at every 5 years or 6 years, if I have to replace those batteries, what is going to be the recurring cost for next 25 years or 30 years? Similarly, if I have installed one system which is expensive at the initial time, but what are the operation cost or maintenance cost of such a system? So all these operation, maintenance, and installation costs, they come into the picture while deciding the energy storage systems as well. Not only the technicality part, the finance part also plays a major role in it. So if I have to bifurcate the energy storage systems into major categories, I would divide them into 5 major categories: thermal, mechanical, electrochemical, chemical, and electric. One of the most prominent and probably used for ages, that is electrochemical technologies, and in other words, or in simpler words, we call them batteries basically. This technology is being used for many years, ages, and this technology is kind of matured as well up to certain level in terms of finance and in terms of technicality. Electrochemical storage technology has become more and more viable. But then there are other options as well, other options available, such as, for example, flywheel or compressed air storage systems in terms of mechanical energy storage. We have thermal energy storage systems, phase changing material. This thermal energy storage systems are being utilized in solar thermal power plants on a very large scale. Like there could be molten salts, or there could be phase changing material. These molten salts or phase changing materials are kind of energy storage system. They capture the heat of the sun, and they are being stored in enclosed environment where the heat is being captured and stored within the within the parameters. And as and when required, these phase changing materials or molten salts are being transferred to heat exchanger in order to exchange the extract the heat, and that heat is being utilized to run the turbines and all. So thermal storage systems are also becoming more and more prominent in terms of energy storage systems. However, they are more viable when we are talking about megawatt scale or utility scale power plants. So these are the major categories. As I said, I would divide them into these 5 major categories of the energy storage systems basically. I'm going to talk about two technologies which are currently being used and which are more prominent. And then I'm going to dive into other technologies as well, which probably might upcome, or we might see them in a near future after 10 or 15 years, which are prominent on paper, but they are still being utilized on what you say, pilot project styles. So one technology, which is a pumped hydroelectric storage system, is kind of a prominent, and it is being utilized for many years now as well. What do we do in such energy storage system is, we have two reservoirs. We make two reservoirs, one at a lower altitude and another one at a upper altitude. And as and when the electricity is being produced during the non-peak hours, like when the electricity is being generated more than the requirement, that electricity is being sent to the pump, which is located here, somewhere here. If you can see them, let me make a pointer. Uh, it can be the pump, which is located on right on the top of the turbine. That pump will suck this water and it will take it to the higher altitude reservoir. Since it is at the higher altitude reservoir, the potential energy of that water is higher. And using the benefit of that potential energy and gravitational force, as and when required, we open the floodgate of the upper reservoir and we let the water drain through the generator, and this will produce the electricity. It is very much similar to the hydropower stations, hydropower plants. Basically, the only difference is in hydropower plants we have a single directional cycle where water flows from higher reservoir to lower reservoir, and probably that water gets run off. That water might not be recovered at all. So it might go to the river, or it might go to the ocean, or some other water body. What do we do here is we pump that water back to the reservoir in many of the cases, so that when and as and when that water is required to generate the electricity once again, that is being stored at the upper reservoir. Now, the critical point here is the energy which is given to the pump to lift water from lower reservoir to upper reservoir has to be much lesser than the energy which is being produced while water travels from upper reservoir to lower reservoir. Otherwise, this entire system doesn't make any sense, right? I mean, if we have to put more energy to bring water up than the energy which is produced while water is being run through for the electricity production, if that energy is higher, that the entire system doesn't make any sense. So in terms of this efficiency, the pump which is being used has to be at a higher efficiency compared to the generator of the water, hydropower plants. Basically, there are various types of turbines used here, like Kaplan and cross flow, and all those entire hydroelectric concepts that we use in electricity production, they are being applied on this system as well. So the basic principle, as I have already said, you can see here that pump and generator. If you see here, this is the turbine generator. It is a Kaplan type of turbine generator, and this one is a pump which brings the water up. So the basic principle here is we use the difference between the gravitational energy and the potential energy from the lower reservoir to upper reservoir, and we bring the water pump, as I have already explained all those things. India has already seen a good number of hydro storage facilities, and many are operational. More and more are towards the south side, but however, in northern side of the northern part of the India, we have quite a few hydropower stations as well. So we have already installed 2.6 gigawatt of pumped hydro storage systems, and they are completely operational in India. 3.1 gigawatt of power stations are under construction, and around 9 gigawatt of these storage systems are being planned, which are under the process. So this is one kind of a prominent technology. This is one kind of prominent energy storage option, basically. Energy storage system. Power plant can be configured mainly in three different categories, like a generator and turbine, they can be having a different pipeline, they can be set up at a different location, and motor and pump, they can be separated at the another level. Such arrangement is known as quaternary set. If we have a motor, turbine, and clutch pump all on a single shaft, on a same shaft, that kind of arrangement is known as a ternary set. The shaft runs in both the directions in this case particularly. If you go into the quaternary set, the shaft runs in unidirectional, in any one directional. If we are talking about the motor to pump, it would run, let's say, anti-clockwise. And when it comes to generator to turbine, it would run in a clockwise direction. But in case of ternary set, it would run the shaft onto the which this motor, turbine, and pump, all three important components are installed. Such shaft would run in both the directions, clockwise and anti-clockwise, as and when the flow of the water is required. Another configuration can be a binary set, where motor, generator can be installed at one point, and turbine, pump and turbine can be installed on the other point. So if you look at the configurations more in more detail, you will see that in binary set there is a single pipeline utilized, a pipeline which is taking water from upper reservoir to lower reservoir. At the same time, the same pipeline is used to take water from lower reservoir to upper reservoir. So in that case, in many of the like in many of the aspects, the cost of the construction can be lowered down. So in most of the cases, binary sets are cheaper. However, they are expensive in terms of operation and maintenance. Whereas in ternary and quaternary, you can see that different types of pipelines and different configuration of the piping is being done, where a single pipe is not utilized for both the operations, for taking water down to up or up to down. They have different operations. They have their own dedicated what do you say, purpose. The a single pipeline is utilized for a single purpose. So this is one of the most prominent energy storage system that we have seen so far, hydropower plants. However, these hydropower plants or pumped hydro energy storage systems, they are expensive. They require a very large area, because we need to store a higher quantity of water at both the places, at a lower reservoir and at the higher reservoir as well. So we need to have a compounding or we need to have enclosing environment where we have to keep all this water stored. So we might need to create the dams, or we might need to have certain reservoirs which have a particular boundary. So they are the disadvantages, or the challenges rather, associated with these hydropower electricity pumps, where the cost of operation and maintenance and cost of building such system is very high. So kind of expensive. Uh, that is one disadvantage. This is they do not kick in very soon. Like they require certain time to start up. So when the electricity is being surged, or it is not being properly injected into the grid, they might not kick in instantaneously. We need to give certain time to warm up the system. Warm up rather, we need to give certain time to start up the system. So there could be some lag, 15-20 minutes of a lag, where the electricity is being injected into the grid. However, the best part about the pumped hydro system, the positive parts about the pumped hydro system is they have both high energy density and power density. Because since we have make a big ponds or big enclosures, we can have higher amount of water stored in it, so that what the amount of water is directly proportionate to the amount of the power. Higher the water storage, higher the power that can be utilized. And not only that, it can run for a longer period as well. It can run for 5-6 hours, because there is no way that you are going to run off all the water from the upper reservoir to lower reservoir within few minutes, right? So it is in high quantity, and that high quantity water can provide the electricity for a longer period of time as well. So let us suppose there is a problem with some renewable energy source for 1 hour or 2 hours. This type of energy storage systems can provide backup for 1 hour, 2 hour, 3 hours. So they have higher power density and higher energy density. One of the most prominent energy storage systems as of now. Another one, my next technology is battery that we have seen for a very longer period of time. The basic principle behind the batteries is chemical energy converted into electrical energy, and electrical energy converted into a chemical energy while charging and discharging. Depending on the type of chemical configurations, we do get different voltages. For example, if I have a dry cell that we use in remote controls, that dry cell or pencil cell is of 1.5 volt. Or if we are talking about the battery utilized in automobiles, in general automobile batteries, which is lead acid, a single cell of those batteries is 2 volt. So depending on the type of chemicals that we have used in the battery, the voltages would differ. These batteries are mainly of two types, primary cell and secondary cell, or rather the cells are of two types, primary cell and secondary cells. The cells which can be recharged, they are known as secondary cells, or the cells which are not being able to recharge are the primary cells. So the pencil cell, the dry cell that we use is kind of a primary cell. We use it once, we use it into the remote, and once it is dried out, once it is completely what do you say, died, we have to throw it away. We are not able to recharge that battery or that cell particularly. Or in case of automobile battery that we have talked about, that is a rechargeable cell, that is a rechargeable battery, because we are able to recharge that battery when we drive the automobiles basically. So there are two major types of cells which are used in batteries, and series and parallel connection of these cells is basically known as battery, right? So a battery constructed when you connect a number of cells into series or parallel, mostly in series, to increase the voltages basically. So that is the battery. Now, as I have already said, like chemical energy into electrical and electrical energy into the chemical, these batteries have been prominent for more than 3, 4, 5 decades. Basically, they have been using this technology for a very longer period of time, and this is one of the most prominent, or rather most used energy storage system, even in thermal power plants or any other renewable energy storage systems where the electricity is supposed to be stored for certain period of time. I'm sure you guys might have seen certain battery bank or certain battery backups in thermal power stations as well, to provide certain backup to run auxiliary powers of the power plant, or even to support the grid. We have used such batteries in our households as well, in terms of UPSs and uninterrupted power supplies, or inverters basically. So batteries are one of the most prominent technology which is being used for a longer period of time. These systems could have higher energy density, but in most of the cases they have lesser power density. And when I'm saying higher energy density and lesser power density, basically means these systems are able to provide electricity for a longer period of time, 1 hour, 2 hours, 3 hours, just like hydropower plants. But they are bulky, and that's why they have a lesser power density. This generally the batteries that we see, they are bulky, they are in big sizes, because we need certain arrangements to keep more amount of electricity stored into such batteries basically. So they have mediocre power density. Let's not say very less, but mediocre power density. uh, these batteries can be incorporated for megawatt of electric storage systems. You can configure n number of possibilities with these batteries, like connect 2, 3, 4, 5 12 volt batteries in series, and you can convert them into 24 and 96 and 120, and n number of possibilities are available depending on the amount of energy that we want to store. One of the most prominent technology in energy storage systems. So higher densities, as we have already talked about energy density versus power density. Limited cycle life. This is one of the major drawback of the batteries. Like these batteries would run 4, 5, 6 hours, so 6 years span. So probably let's on an average, we might need to change the batteries every 5 years. So this is a recurring cost basically. It is not just one-time cost, just like hydropower stations or pumped hydro storage systems basically. So once you have installed it, once you have developed such environment that will last for a very longer period of time, 25 years, 30 years, 40 years. That is not the case in particularly in battery. These things will last 5 years, 6 years, and every 5 to 6 years, this is a recurring cost. So it is kind of a cost that you have to keep in mind while designing the power systems or energy storage systems starting from the day one, basically. So we have already talked about the different types of cells. These are the primary cells and secondary cells. Now, these two were the most important or the prominent type of the energy storage systems. I'm going to go over towards the pilot projects or pilot energy storage systems, which are not quite prominent, which we might not have seen on a very regular basis, on a daily basis, but are still prominent, which we might see in next 10 to 15 years. And one of them being a flywheel. This is not a new technology, guys. This idea and the concept is being in the engineering background for many years. However, due to certain reasons, it has not been implemented for a very long period of time either. So, what is the concept of flywheel? What is the principle of flywheel? Is that when we provide electricity to the motor generator associated or connected on a shaft, if you see this shaft here, it is a shaft where a motor generator is connected. When electricity is being provided to the motor, the motor will make shaft rotate in one particular direction, and that will convert into the kinetic motion, basically the kinetic energy that is being stored into the shaft. So the shaft has a kinetic energy now, right? And now, as and when required, the same shaft which is rotating in a single direction can make the generator run, which is connected on the top of this shaft as well. So there is a motor, there is a generator, and there is a shaft, which are all three in single direction. The same shaft can make the generator run as well. However, the motor and generator, they don't run together at the same time. So when we are injecting the electricity to the shaft, the generator is not working at that point of time. And when we want to produce the electricity, motor will stop running. So the shaft, when it is rotating, it will provide it will make the generator work, and the generator will provide the electricity, and that electricity is being injected to the grid. Now, to reduce the frictional losses, because it is a mechanical part, right? These all are the mechanical parts. So to reduce the friction of the entire system, this shaft and motor generator, they are encapsulated in a vacuum chamber, so that the frictional losses and other mechanical losses can be minimized. They can be reduced as much as possible. So there is a carbon fiber composite flywheel. The entire chamber is vacuumed. The entire mechanical losses are being reduced using rubber bearings and other less frictional materials and everything. So this flywheel is able to provide electricity backup for, let's say, maximum up to 60 seconds, 1 minute or something. The flywheel can provide electricity from 100 kilowatt power station to 2 megawatt of power station, for example. But higher the power station, lesser the time duration it can provide the electricity as a backup. So let's say if I'm saying I have utilized this flywheel for 100 kilowatt of a power station, and for that 100 kilowatt, the flywheel might be able to provide electricity up to 60 seconds. But the same capacity of the flywheel, if I'm going to incorporate that into 2 megawatt, it will provide electricity for 2 to 5 seconds because it is providing higher amount of electricity, higher amount of energy, and since the entire capacity is the same, the duration will decrease. So obviously, in other terms, we can say that flywheels have lesser energy density because they do not provide electricity for longer period of time, 60 seconds, 90 seconds. Like, it is in minutes. It is not in terms of higher duration. And as we go on a building bigger flywheel, obviously the cost of the flywheel will increase. And at certain point, it becomes illogical to make a bigger flywheel for a more energy density for a longer period of time, right? Because the entire cost of the energy storage system, that becomes very expensive, and that does not make any sense to incorporate such systems if we go for very long, very bulky or very large flywheels, basically. So this is the concept or the principle that I have said, like the momentum or kinetic energy which is being stored in the shaft, mechanical inertia as a principle that is being utilized to run the entire system. As I have said, like it can run from 100 kilowatt to 2 megawatt from few couple of seconds, like 2 to 5 to 10 seconds to 60 seconds. It can provide the electricity for a very longer period of, a very shorter period of time. If we incorporate that for 100 to 120 kilowatt of a power plant, it might give electricity up to 60 seconds. For 2 megawatts, it might be 1 to 2, 3, 4, 5 seconds. Basically, it's not bigger than that. So as I already said, what is the disadvantage? The disadvantage is it has a very less energy density, but yes, it has a high power density. So it can store more power, but not for a longer period of time. See, the concept behind the power density and the energy density, the difference behind the power density and the energy density, it can store good amount of power, like up to 2 megawatt. That is a good amount of power, right? 2 megawatt can be stored as a power, but not for a very longer period of time. So the energy is not higher, energy density is not higher, power density is good. So it might work into certain power stations where you require electricity for as a backup. You require electricity as a backup for very small period of time, basically. So that is low energy density. It has a very long period. That is, it has a very long life. My mistake. Sorry, it has a very long life. That is one advantage of such system. That once you construct it, it will run for 20, 25 years, so 30 years. So it's unlike battery. You don't have to change the entire system every 5 to 6 years, right? So it's not a recurring cost other than the operational cost. Yes, operational and maintenance cost. There is certain maintenance cost associated with any systems anyway, right? I mean, so of course, it has very low environmental impact. That is one of the best what is the positive side of the system, because since this all system is mechanical, there are no hazardous chemicals utilized in flywheels, unlike batteries. Like in batteries, you have lead, you have certain acids, you have certain, let's say, cadmium. So these are certain components which are hazardous to environment when you discard the battery, right? So in terms of flywheel, there is no environmental bigger environmental hazards. There are certain pros. At the same time, there are certain cons or the challenges associated with the flywheel. As I say, this system is still being utilized on a pilot basis. Another prominent technology which we might see in a very near future is electrochemical cells or electrochemical capacitors, supercapacitors, tetracapacitors. I'm sure you guys might have heard about the ultracapacitors, supercapacitors, which is being one of the most prominent technologies, and we might see this technology in automobile very soon. Probably we might see this technology in within 5 years down the line, replacing the batteries. This is one of the most prominent technology which might be able to replace the batteries in terms of energy supply and the storage. So what is the basic concept or the principle behind this electrochemical capacitors is just like a normal capacitor which stores charges, like battery stores energy, right? But the capacitors store charges. The capacitor stores positive charge and negative charge. It has chemicals, and the chemical is being sandwiched by two different plates. There are two different plates which has a chemical known as electrolyte in between these two plates, and this electrochemical system is being broken down into positive ions and negative ions, and positive ions are being deposited on one side of a plate, and negative ions are being deposited on the other side of the plate. This is the basic concept of the capacitor, right? What is difference in supercapacitors is the gap between these two plates are very small. That is being reduced, and number of plates are being increased, so that the barrier between these two plates is being reduced. When you reduce the barrier, basically you are reducing the resistance, and because you are reducing the resistance of the entire system, the flow of the charge that becomes easy. And when the flow of the charge becomes easy, you get more capacitance, basically. So what do we do in supercapacitors here is a supercapacitor is double layer capacitor that has a low voltage limits. So the resistance is basically reduced in the entire system, and electric field is being created on both the plates, positive and negative plates. And these plates store the charges, and as and when required, these charges are being combined, and the electricity is being produced, basically. So capacitors use static electricity rather than the chemistry that stores the electricity, as in battery, as I have already said. Positive, negative ions are being charged or stored on the two sides of the boundaries, the plates, basically. A supercapacitor differs from ordinary capacitors in two ways, as I have already said. Its plates effectively have much bigger area, and the distance between those two plates is very small. As I already said, these things, the separator between them works in a different way than the conventional dielectric systems, basically. So the supercapacitors, since it has a larger area, they have a higher capacity to release the charges, because of the higher surface area, basically, and that this distance is being shortened out as well. Supercapacitors will store electricity for a longer period of time, so we can increase the energy density. But at this point of time, compared to the battery, they have a lesser energy density, which the concept in the research of electrical supercapacitors is to increase the energy density, basically. They have higher power density, longer life, but lesser energy density. They are expensive at this point of time. But if I have to bet on upcoming electrical or energy storage system, probably I will bet on supercapacitors, that this should become one of the most prominent energy storage systems in very near future. And probably I see them as a replacement of batteries as well. I mean, this is my personal point of view. Another prominent technology, that is superconducting magnetic energy storage, also known as SMES for short. What happens in this, as a principle, we have a superconducting coil. So that superconducting coil basically is made of superconducting material. And what is the principle of a superconducting material is, after certain temperature, that superconducting material feels zero resistance in theory. When we reduce the temperature, when we decrease the temperature of this material, the resistance within the material that will reduce. So after a certain point, it is theoretically zero resistance. So what do? Is we insert this superconducting material in liquid helium or nitrogen to reduce the temperature of the entire superconducting coil. Let's say minus 100, minus 92 degrees Celsius or something, right? And when this minus 90 to minus 100 degrees Celsius material temperature is being surrounding this superconducting coil, the resistance within the coil becomes zero. Now, how this behaves as a energy storage system is, you see this as a conventional power plant. This is a conventional power plant where electricity is being produced by motor and pump and compressors and all. That electricity is being injected into the superconducting coil, and it is being stored over there for a certain period of time. Because there is a zero resistance in theory, that electricity which is being injected into the superconducting coil is not going anywhere. It is stored within the superconducting coil material itself in terms of magnetic induction, right? And that in terms of magnetic induction, that electricity is going to be available within that coil up to certain period of time. As and when required, we can make the changes in the magnetic field, and when we do the flux, basically magnetic flux, changes in the magnetic flux, that electricity is being produced in form of DC electricity through the magnets, through the coil. So as you see, the electricity is being injected from these two terminals, a positive terminal and negative terminal. That electricity is in form of DC, basically. And when that is DC electricity is supposed to be injected into grid, it is supposed to be converted into AC, and hence we have this PCU, power conditioning units, or PCS, power conditioning systems, which convert DC electricity into AC electricity, very similar to those solar systems, basically. And we have inverters in these solar systems. So that electricity is being converted into AC, and as and when required, it can be injected into grid. Prominent technology, but very expensive at this point of time. So induction or inductive energy stored in magnetic field as and when required through the superconducting coil. That DC electricity is converted into three-phase DC electricity and being given to the grid. Possibly good energy storage system, but I might not see that. Probably this type of technology might not come into the actual economical application in very near future at this point of time. So it has a higher power density but lower energy density. It cannot provide electricity for a very longer period of time, just like hydropower or batteries, basically. Very expensive, costly. I'm going to talk about the last energy storage system, which is very simple, very easy to maintain. Well, no, sorry, my mistake. Not very easy to maintain. Very simple to construct, but difficult to maintain at certain level. What happens is, we create certain crates underground. We create certain, what do you say, voids underground, and we inject this air, open air, into this underground, and we store that air into those reservoirs what we have made underground, basically. So if you can see here, the air is being injected throughout the series of compressors, low pressure, intermediate, and a high pressure compressor, and that air is being pressurized throughout each stages, after stage by stage, basically. So a low pressure compressor will compress the air up to certain level, then intermediate, and the high pressure, it will compress the entire air on a large scale, and those air is being stored under reservoir, in the reservoir underground. Now, as and when required, this air is being pumped out. You don't need any specific kind of a pumps to bring them out, because it is already being compressed and stored into the reservoir. It has high pressure within those reservoirs, right? So as and when we open the valve, this high pressure air comes out, and it passes through series of pressure turbines. Because it is having a high pressure initially, it passes through high pressure turbine first. That high pressure turbine air will pass on to the low pressure turbine. It is kind of a wind turbine. These are kind of another nature of the wind turbine. I mean, wind turbine, they turn when the wind blows. Similarly, this air which is in motion, is wind. This compressed air will run the high pressure turbine and eventually low pressure turbine to produce the electricity. That electricity can be injected into the grid. It is kind of a simple on paper, but it requires very large area. It is very expensive to construct, and we might see that in near future. I'm not sure. I cannot bet about anything of this, but the best part of this energy storage system is it has both high power density and high energy density. So other than the costing part, this is technically prominent technology, basically. So these are certain types of energy storage systems that I wanted to talk about, 2 of them being used on a regular basis and 4 of the other technologies which we might see in a near future. I open the forum for the discussion or the question answer sessions if you have any. I might have gone through this technologies.
I am Dr. Damija from Skill Council.
Yes, ma'am.
A very nice and a very detailed presentation. I'm really impressed. It was, I tell you, the way you have covered the entire energy storage systems in one presentation, I would like to compliment you. There are 1 or 2 questions I want. I want to know more about, when we were doing about batteries, I had done a report on batteries. So we had seen that lithium ion is the future and metal hydride is the medium term. So is there anything which has been done on metal hydride batteries, or have we lost the race because there were so many issues in terms of, the weight penalty in terms of the efficiency? So we had done a lot of work in Banaras Hindu University. There was a hydrogen center, if you remember, Dr. Owen Srivastava was there. So there, and then on sodium batteries, I understand that China has made some battery cycles with sodium batteries.
Sodium metal hydrides.
Yeah, right. And some work going on in UK. I had attended a presentation. There was one company who wanted to come and work on sodium batteries. So can you just give me some update on this?
Ma'am, in best of my knowledge, the entire economical or the commercial side of the research has been shifted towards the lithium ion, like lithium phosphates or lithium ferrophosphates and lithium ion batteries and everything. So in best of my knowledge, as of now, people have been moved away from metal hydride batteries, and they are particularly focusing on the ion batteries, like lithium ion batteries. And
lithium. Okay.
That
is environmentally safe. Lithium ion is more safe, I feel.
Lithium ion is more safe. However, at the same time, it has a higher DOD. We can have a higher depth of discharge of lithium batteries, basically. So so that provides one benefit over the other hydride batteries, basically.
And sodium?
Sodium is possible, but then I don't think that much of the research is going on in that way, because people are more focusing on the lithium at this point of time because of due to the availability of the material and possibility of higher DOD.
Yeah, and these super capacitors and flywheels, are they only in stationary energy systems, or we are making them use in the mobile sector also, the automotive? Flywheels, I think they can be used, regenerative braking. Yeah.
Flywheels are being used in regenerative braking, and it is actually possible. So within the automobile sector or the mobility power sectors, in terms of semiconductor. Sorry, did you say supercapacitors as well, right?
Yeah.
So supercapacitors are also being used in mobility sector, and as I said, I mean, probably in very near future we might see them replacing the batteries in terms of automobile particularly. So flywheels are very common in automobile sector. Yes. So they are being used in mobile sectors.
So thank you once again. Very good presentation, and thank you
my
for
pleasure,
answering my questions. Thank you.
My pleasure. Thank you.
Thank you, Mr. Japen. Anybody else from participants who wants to share your thoughts and or any question? Okay, okay, no questions from participants. So
Thank you, Singh sir.
we are going to wind up the presentation. Thank you, Mr. Japan.
Thank you very much, sir. My pleasure. Thank you very much for inviting me to be a part of wonderful event that you guys are organizing. My sincere thanks to Saxena Sahab, Vibhas ji. Thank you very much, Singh Sahab. Arpit ji. I'm glad to be a part of this. Thank you very much.
Yeah. Thank you very much.
Thank you. Thank you, sir.
Thank you, sir.